All right, we're back. It is COMP123, that's Programming 2 in the summer 2016 semester. Week 5, part 3 of our broadcast, second day. It's Friday, thank God, right? Some of you might enjoy the weekend. Remember that your next assignment part, right, is due when? Tonight, right, at midnight, right? I want to give you some tools today to help you construct your classes and your objects and those kind of things. And we're going to use the assignment that we've been working on so far, this little lesson. I'm pulling up COMP123 Summer 2016 Lesson 5. You can all, that's the one we've been working on from last day. Excuse my voice, I'm still a little bit under the weather. 2 weeks. It's crazy. Summer cold. It's all Joanne's fault. I have to give her some credit there. Joanne, it's your fault. I'm joking, of course. So when we pull up our classes and objects here, let's take a look. I've got a cards and deck. Some people were confused about some of the stuff we did last day. So how do I make it better? How do I make this more visual? Because some people are visual learners, and other people are more technical. They can look at the code and they understand what's happening. I'm kind of a bit of both. I'm kind of a visual learner. I like to see connections, between one thing and another, and I also like to look at the code, right? So Visual Studio gives you some amazing tools to do that. And so let's talk about that. If you have Visual Studio Enterprise 2015, if it's not just Community Edition or whatever, even some of the other editions as well, they have a different template that you can use. Here's the template that I'm talking about. I want to go to the project. Let's go to the project, right-click onto it, and go to Add. And instead of adding a class like we normally do, go to New Item. And I want you to scroll down until you see, if it's available for you, something called the class diagram. All right. So if you actually type in the search field, if you go class, right, it'll kind of filter by class. Notice down here there's a class diagram, right? Some of you should be able to see that. Who cannot see class diagram? Might be a version thing, right? That's awesome. So if you all can see class diagram, let's call the class diagram the name of our lesson. So it's like, for example, lesson 5, class diagram. Then press Add. But we said we start off with this blank slate, right? And it's like a canvas that's empty. Notice it says you can use the toolbar to do stuff. Okay, we're going to do a few different things today, so just bear with me while I do this, okay? And I want you just to open your minds a little bit, because some of this stuff I don't want to lose you. I want to drag the card class, here's my card class, onto the diagram. All right, so here we go. Boop, here's my card class. I want to drag the deck class onto my diagram. Boop, there's a deck class. Okay, and I want to drag the program driver class onto the diagram. So I have those three things kind of on the diagram. Now, there are some professors who are going to tell you that I shouldn't show you this stuff because this way, you don't have to code anything. The truth is, it does create some code for you. So I'm going to show you both ways how to create code with this stuff. It structures your code a little better. But in real life, I'll tell you right now, I use whatever I can do to code as fast as I can, right? Let's be honest with you. And as structured as I can with less errors. And this is what this allows you to do. Okay, right now, it's just a few boxes, right? If you click this expand button over here, right? Remember, this is why this is Visual C#, all right? You can see the properties and methods of my card class. This is good. Right, same thing with my deck class and with my program class, right? So you can see the properties and methods here. One thing to note is up here in the controls, if you have the same version as I do, you can do things like, if you click this one, this icon here, this is display names and type. So if I go click this one, all of a sudden, not only the names, but also the type that they are, right? Names and type. I can also click this one, which is the full signature of the method or property, right? Now, see how this is cut off? If you click this little icon right here, this little thing, it'll actually expand the shape of your class to fit, so you don't have anything cut off. All right, so why is this really good? I mean, one thing, it gives you kind of a visual snapshot of your classes. But again, I'm a visual person, right? I want to be able to look at this stuff and go, I see now how things are related. For example, look at the deck class in here. The deck class shows us that we have a class, and there's a little arrow next to it that says list card. List card. That's neat. And what it allows us to do is also take a quick look at all the methods. Here's the methods that the deck class has, as well as here's a program. Here's my program class with my main arguments, right? One thing it doesn't show us right now for the way it looks is there's no links from one class to the other because they're not really linked. I didn't inherit the card class. Deck it doesn't depend on the card class necessarily. I mean, it uses the card class as its derived class, but it doesn't do that. One thing I can do with this, though, is I'm just going to give you some room here, and I'm going to just unpin this so we can have some more room on the diagram. One thing I can do is if I right-click on the actual diagram, I can show something like a base class. So if I go to the base class, I'm going to drag this over here for a second. You can see that the base class, and I can rearrange my diagram so you guys can see this a little bit more, right? You can see that the base class here is the list class, right? The list class is the base class for my deck class, right? Because it is a list. A deck is a list. And notice that it has a bunch of these other things here. These are all interfaces. So a list not only is its own class, and I can show you the details. If I expand it, you can see that my list class is massive. That means, and this is why it's important for me to see this. Let me just get the program class out of here, put it down here. That means that the list class, in all of its glory, is massive, right? So what am I doing here? That's why I wanted to bring it up, so you can understand inheritance. When I inherit the list class into my little deck class is not little. My little deck class is massive, just as big as this, plus it includes other stuff that the list class does not include. All right, so it has all this capability. I can do, so here's some properties. I can do a count, because count is part of the list class, and so it's part now of my deck class. I can do a deck.count, and I can count how many members are part of my list. I can do other things in here, like, for example, the add method that we've been using. This.add adds a list item to the deck class. The list items, of course, are of type card, right? Card class, because a list is a generic. Notice that list has this T next to it. T means type, right? So when I declare a list, I have to also declare its type. My type of list for the deck is card. It's a card type. Here's my card type, right? So you can see that it has lots and lots and lots of methods. These are all the methods. And I can even actually open this up for even more, right, to give more details. Nested types that I have in here. IEnumerator, IDisposable, and so a bunch of other stuff here in a struct. Now, some of you, when you look at this, may go, so what does this mean, Tom? Thank you very much for making me more confused, right? I don't want to confuse you here. I want you to understand the relation. The arrow in the diagram, when it points from deck to something, it means that it inherits from. That's what the arrow diagram means. Okay, I want you to understand diagramming. When you see this thing, you understand. And sometimes when we create stuff like when I'm involved in a project, right? I draw my diagrams. This helps us with project management because it tells me when I'm constructing my classes how everything is related. Now I can disclude an object from my class diagram by right-clicking and by basically removing it from the diagram. It doesn't delete the class, it just removes it from the diagram. All right, so that's a lot of detail. I don't need to see that all the time, right? And that's why I did that. I can also include it again. I can show my base class, and I can show it in its base form. Like, for example, I don't have to show all the details like I did for this one, right? This is hidden. I can see that it derives from list if I really want to. Let's just remove it again. So this is neat. And how does it help me? Well, remember we talked about enums. I talked about enums. And in enums, right, I said, hey, you know what? The idea that I have going on for my my card class and my deck class and all that stuff, it's nice, but it's not really that accurate because I'm using like strings for suits and numbers for faces. And really what I want to do is establish a more contextual, way of expressing the card, right? Because remember, I'm trying to derive something from a business rule. I'm looking at the real world situation. I'm trying to take what I see in the real world and express it in code, right? That's what I'm trying to do here. So Again, a little bit of a complex concept. But let's say, example, you don't know how to do an enum. Let's just say, right? And you want to add an enum here. Well, if you go to my toolbox on the left, right, you can see that I can add a bunch of stuff. Enums, interfaces, abstract classes, structs, all kinds of stuff. Let's drag and drop an enum onto the page. Whoop. There we go. Now it tells you what's the enum's name. Remember, an enum is an enumeration, right? Like, for example, the suits. I want to do an enum for suits. So let's do that. So we'll call this enum suits. Do it with me. Could it create a new file called suits automatically, right, in my project, right? Let's do this together. I'm going to press OK here. Here's suits. It's a visual representation of an empty file. If I double-click on any one of these objects, like suits, I can see the code that's behind this thing, right? Let me show you suits. There's suits. So suits is really an enum type, right? Right now it's suits. And it doesn't have any members in here, right? I can code it by hand, or, right, I could get the class diagram to do it for me. Let's do it. So I'm going to right-click on the class diagram. I'm going to go Add Member, right? And let's start talking members. I want to do it alphabetically. So the first member is going to be clubs, right? And nothing's depending on suits right now, so we can do this with impunity. Clubs, diamonds, right? Add member, hearts. Add member, right? Spades. Right. So we've got some members inside my enum. And you're going to like, okay, and remember what an enum is. It's just a visual representation of some known values. Almost like gives me only these values you can choose from your enum, right? So I only can choose clubs, diamonds, hearts, or spades. I can't choose something else because it doesn't exist within that structure, right? And in real life, I don't have other kinds of suits in a regular playing card deck. If I was playing Magic, right? If I was doing Magic the Gathering, then I wouldn't have just clubs, diamonds, hearts, and spades. I might have something else, some other kind of structure. Or if I was using tarot cards as an example, different kinds of cards, I wouldn't play cards with those, like a game with those cards. But if I was using tarot cards, it wouldn't just have clubs, diamonds, hearts, or spades. I also would have, the major arcana to deal with, right? Not just the minor arcana. And clubs, remember, just as an aside and a digression, common playing cards today came from the tarot deck, right? It came from, instead of clubs, it was staves, it was diamonds, it was coins, and hearts were cups, and then spades were swords, right? So that's where it came from. It derived its names to what it is today. It evolved into the modern playing cards. As an aside, but we digress. So I've created this enum, and I can double-click on it now, and I can go back, and you can notice that my enum is full. It has clubs, diamonds, hearts, and spades. It actually did the code for me, right? All right, so I'm going to use this. Just bear with me, but we haven't used it yet. So far, I've created an enum, clubs, diamonds, hearts, and spades. I want to do another one, right, for my faces, right? Because remember I told you, there is no one in the faces. There's an ace, a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, right? It does that. But really the ace, if I was going to play war with my cards, is the highest valued card. It'd be, for example, a 14, right? How do we express that with a enum, right? So I'm going to do the same thing. I'm going to right-click here. Instead of drag and dropping, I can also go Add Enum, right? And in my enum, I'm going to call this Faces. Right, here it is. Now I'm going to add some members. Let's add them in. That's going to take some time, so you do it well with me, please. Don't watch me. Please do, so you understand how this works. So I'm going to call this 2. Oh man, well, why did I make it a named, like a value like this? Because that's what an enum is. If I'm going to store just values like 1, 2, 3, 4, 5, an integer, I don't need an enum. I can use an integer, right? 2. I'm going to stop here before I go on. I'm going to double click on my enum for a second. And one thing you can do with an enum is tell it where to start. So an example is my 2, right? If I hover over it, notice that my 2 has a value of 0 when I hover over it. That's not right. 2 should have a value of 2, right? 3 should have a value of 3, and so on, right? I want to start it off right. So what I can do is I can go like this. I can say 2 is equal to 2. Bear with me while I do this. So what I'm doing is I'm saying start the count at 2 for my enum, because 2 is a 2. I want my letter representation, the TWO that represents 2, right, to actually be equal to 2 when I do any calculations in the future. So I'm going to have to compare one card with another card, and I want to know that a value of 2 is greater than a value of 3. All right, as an example. And I want it to be accurate, all right, especially from a points perspective. Okay, so how do I add more enumerations? Well, I just keep doing this. I'm going to add the next one. Member 3. Let's just add them all in. Member 4. I can do it this way. Or if I really want to and I'm really bored, this is driving me crazy, and I can type faster than this, I can double click and I can do it just like this. 5, as an example, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Now when I do this, if I hover over the ace, I get my value, which is 14, right? My value for my ace is 14 because the enum starts at 2, starts counting at 2. 2, 3, 4, 5, 6, all the way down to ace, right? Why is this valuable, right? Well, because it's a contextual representation of my cards as opposed to a number. The number doesn't mean anything. It's not contextual. It's just a number. Whereas this is more realistic in terms of what my cards would look like. There are 2. There are an ace. There are 3. It's not the number 3 necessarily. All right. So, well, if I save this thing and I made changes, automatically I can see that my enum on my diagrams also changed. Let me just push this all down a little bit so you can see everything correctly. I can select multiple objects here, right? And I can move them all down at once, just from a diagram perspective. There it is. Faces and suits. Okay. Now, what am I going to do to you next? I'm going to change my card to use suits and faces as opposed to integers and strings, because it doesn't make any sense contextually that it would be a string type. I want to make it more realistic. So here's my card, right? Again, you can play with this value here. Let's double click here and see how I can do this. So right now I have int face. This is my property with a getter setter, right? But it's an int. And what I want to make it is of type faces, right? Getter and setter is okay. This is automatic property, but I want to change my type from int to faces. All right, that does it. And how about this one? String to suits. Okay, string to suits. Now there's going to be a problem later on. Can anyone discern what the problem might be later on down the road? I remember I'm creating my card type, and I'm creating another object of the card type later down in my base, right? I've been using faces and suits as integers and strings inside my deck class. They're not integers and strings anymore, which means my deck class has to be updated. All right, just saying. And this is wrong too. Even my comments are wrong. This is faces, right? And these are suits, right? Also, this is wrong. My constructor from my card class is also wrong now because it doesn't take integers and strings. It takes faces and suits. So let's do that. Faces and suits. Now you can see that there's no problem. So my card class is correct, but I've got more of an abstract idea of what faces and suits are compared to the actual number and string. It's not a number and string anymore. It's faces and suits. Right? The program will take care of the logic for you in the background. All right, we got some issues. You can see that my card has been updated with face and suit properties, right? And here's my card method, right? And let me just expand this thing so you can see the full signature. For now, we can just make these a little bit. We can kind of mute these. We know what those are: faces and suits. And this is my card class that depends on faces and suits. So I'll just put them like this, just in the diagram so you can see how I can lay this out. For you, it's all about visibility. It's all about understanding what I'm doing here. So my card is made up of faces and suits, not strings and ints anymore, okay? I need to update my deck class. Here's my deck class. And this is where the big work has to be done, right? By the way, my program class won't care. It doesn't care what happens because it really takes its cues from my deck class. if I looked at my program class right now, you can see that I do decks and shuffles, and there's no errors because it doesn't know what a deck is. It doesn't know what a card is. All it knows is that I'm going to perform the stuff in my that's part of my deck class, right? Okay. So we need to fix my deck class because it's broken now. I've broken my deck class because of the breaking changes I made in my card class because I've changed the type. Let's explain. So if I double click on my deck class, you can see that I got some issues, right? And one of the issues is I have this hearts suit thing that I'm doing when I create my deck. I got to fix it right here, right? And it's pretty darn ugly. Remember we talked about this and I said, there's a better way, guys. I swear there's a better way. Well, let's leave this the way it is, but just comment it out. I think it's good to comment it out so we can see it. We'll put it in deep freeze, or I don't know, you want to call it whatever you want to call it here. So I want to kind of comment it out, this piece, all the way down to here, right? So right here, we're just going to comment it all. So basically my lines would be from line 49 all the way down to this. And I also want to comment this piece out here, this string, because it's no longer a string, right? All right, so we have a for loop, right? We have a for loop, and we're like, for loop, how can I do a for loop that goes through a suit? I'm kind of like, iterating through an enum. I'm not iterating through an integer anymore, right? So actually, let's put this little comment right here. Let's put this comment out stuff. I'll take it, and I'll even put it in front of this. Let's replace this. So all this is commented out now. So I have no functionality within my create deck method yet. Let's add some spaces here, and we'll make our own little functionality happen. Let's rewrite the create method. All right, but we're going to use a for each loop, and I want to go through for each of the enumerations, right? Each of the enumerations, I want to do that and create an outer for each loop and an inner for each loop. Okay, this is what the beautiful thing about enumerations. Watch. So for each, and I want to declare my first one is suits on the outside. So I'm making an item of type suits. We're going to call it suit. Now in the collection, this is where we do some different stuff here. In order for me to get the value of my enumeration, right, I need to do a static class called enum.getValues. Right? And inside my getValues, I want to say type of, and then inside my type of, I want to specify my suit, right? Suits. I have enough brackets here. 1, 2, 3, 4. Yeah. And then one more. There we go. All right, what am I doing here? What's this enum get values type of suits? I'm saying for each suit in suits, for each suit, so hearts, clubs, whatever, I'm going to attach a value to the suit. This suit is going to change. It's going to iterate through the entire enumeration. It's going to go through each of the enumerations, starting with clubs, and it's going to go clubs, diamonds, hearts, spades. That's what it's going to do. All right. That's the first outer enum that I'm having. I'm hitting suits first. Then let's do another for each loop. Inside the middle one, it's going to be faces, right? Suits on the outside. So for each suit, I want to have X number of faces, 14 faces. But I can't iterate it through a for loop anymore. It's got to be through a for each or some other kind of structure. So I'm going to do the same thing. Faces, instead of item, it's going to be called face. My collection is going to be the same idea. So I'm just going to copy this piece, enum, get values, copy this whole piece here, and put it over here. And instead of suits, it's going to be faces because that's the kind of enum I'm hitting. All right, so I've got two for loops, one on top of each other, right? So what I'm saying is here, first iterate through my suits, and for each suit, I want 14 faces, right? That's what I want. Now comes the great part. If I scroll down, you can see this line right here, this add new card face suit. I'm going to copy this line right here. Copy and paste. And guess what, peoples? We're done. That's it. Those two for each loops is equivalent to all this. Let's test it and see if I'm right. because it was important for us to see if I'm right. All the rest of the code that we have is cool because it doesn't care. It's using the same Fisher-Yates switch that we did last time. All that stuff works the same way. Even the display, you'd be surprised. When I call up to display an enum, it doesn't give me the value of the enum. It gives me the actual contextual name of the enum that I'm going to get, right? So I get like a face in writing, like 2, and a card, right? And the way to test this, of course, is can I kill some of these spaces here for you guys to see? The way to test this, of course, is to use my driver class. I'm going to say, first of all, let's update my diagram. Notice that I made some changes, and you couldn't see the changes here in the diagram because one thing it doesn't show in the diagram is the details of each of the methods. All right, just tells you if it's private or public. We'll talk about these little dots and what they mean. But what I can do is I can go Control F5 and to test it, right? And here it is, right? But instead of getting that 1, the number 1, or number 2 of hearts and 2, I get the actual value now. So now it's the actual value of my suit. So here's what it first comes off. My current deck is the 2 of clubs, 3 of clubs, 4 of clubs. This is how it counts. So it starts with clubs first, then iterates through diamonds. This is how it constructs the deck. Then it goes through hearts, finally finishes with spades, with the ace being the last card because it's the highest ranked card in the deck, right? And then when I shuffle, notice it goes 4 of clubs, 5 of diamonds. Oh, this is wrong. I typed king instead of king. Let me fix that. So I made a mistake in my enumeration. That's okay. Takes 1 second to fix. All I have to do is, that's why we test. All I have to do is go back to the class diagram. Yeah. Sure. Just a moment. Are you talking about here in my deck class?
Yeah.
So you want me to go back here to this? Yeah. Same thing. I didn't touch this piece at all because a card does take a face in a suit. But my faces and suits are now faces and suits, not integers and strings, which makes more sense. So everything is more contextual than it was before. It means something more, right? As opposed to a number and a string. A number and a string are cool if you can't make your own context, right? But you want to try and, again, you want to try and map what we see in code to the real world as much as possible so that it becomes more realistic when it comes to how we deal with the code, right? It still sorts it the same way. I'm still shuffling the same way. They're still cards, but my card objects are actually more complex than they used to be. Right now, a card object each has a face and a suit attached to it, and they can only have, for faces, they can only have those 14 values. I can't load another type of value other than a face to the card, right? So if I put some other value in there, it's gonna give me instant validation feedback saying, I'm sorry, but you give me an integer. What is this? If I try and load something else into the card, it's gonna also give me some other issue. It's gonna say, what is this, right? An example of that would be if I wanted to create a new card. I'm just gonna do this as an example. If I say like my card, so card, my card is equal to a new card. Look what it asked me for. It asked me for faces. It immediately takes me down to faces, right? And suits. So if I have to do something like this. I have to say faces dot, and I can choose one of the faces in my card. These are the only options I have. I cannot put in something else. If I try putting in my own, like faces, I don't know, double ace, right? Something like weird like that, right? It's gonna give me an error. So there's no double ace in the faces, right? I can only choose from 2 to ace. There's no option here. But if I go ace, we're good. And if I go, as an example, faces, if I look at the next one is suits, right? So I can go suits dot, and I can choose one of the suits. Suits, clubs, diamonds, hearts, right? So ace of clubs. Right? It's more contextual. You can see the card. I'm adding in an ace of clubs now. I know what it is. I don't have to guess. What's a 1? What's an 11? I don't know what an 11 is, right? But I know what a jack is, right? Jack of whatever the suit is. So that's why we make it more contextual. Here's a problem that I ran into. How come it did this? COMP123, give me my instead of just doing card, I mean, it give me this right away, right? If I want to do card, is that incorrect? No, it's IntelliSense acting up here, right? It's still part of the same namespace, my enums, right? It didn't create its own namespace. Like my main namespace right now is the name of my lesson, right? It's almost like the same package we're working with it, or the same project, the project space, right? And so, you know, COMP123 Summer 2016 Lesson 5, notice that that is what it is for the deck class. And if I go back to my Solution Explorer and double-click on one of these enums, like, for example, faces, you can see that it's the same namespace, right? So an enum, just to go over this again, is a collection, hear my words, it's a collection of objects that we define user-friendly names for, right? In English, typically. For example, the days collection would have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Those are all the days of the week. You might call it days of the week collection or enum, right? And then if I ever choose a day of the week to be more accurate, so I don't choose like number 8, because there is no one number 8. And if I want to start counting each day of the week by starting at 1, I could say, just like I did here where I said 2 is equal to 2, I could say Sunday is equal to 1. Monday will be equal to 2, second day of the week, and so on. And I can count that way if I wanted to create that proper syntax or whatever. Right, that's what an enum is. It helps us count, but it creates a context for us. Okay, so now that we've done that with deck, we can clean this stuff up because we know that we don't need all this. So let's get rid of all this code, and you can see that, and all this, and this my card example. You don't need this my card example either. We can get all this code right here, all the way down to the bottom, right? All right, we're going to make another commit because we've added a couple of things here. We've added a couple of enumerations. Look how beautiful my little create class is. This is elegant compared to what it was before, right? Before, it was brute force ugly, all right? I don't want to do brute force ugly code. I want to make it as elegant and optimized as possible. This is much more optimized, and it actually will run faster than the other way, right? I don't have to do a switch statement. A switch is a glorified if else, if else, if else. I'm not doing glorified if else's here. I'm not even doing if anything here. All it's doing is iterating through my loop, each of my enumerations, and adding it into my card. I'm loading my card up with a bunch of enumeration types. So there's no if else involved at all, or switch. All right, let's do that. So let's say Team Explorer. I'm going to hit my changes. I made some changes to stuff. I've added my faces and suits, right? And I've updated my cards. So I'm going to say something like added faces and suits. That's what I've really done, enumerations, enums, right? And I want to add all these commits in there, save all this in, and then commit staged. I'm going to go home, and I'm going to sync and push. Right? There we go. So now on the GitHub repository, you'll have all my changes. So you can always go through and compare my code with yours. Yeah.
Can you mix the number and text together in a single enum? For example, 1, 2, we have written down one text. Can we do it, for example, and show the number rather than the text?
No. It takes away the reason for the enum. You're thinking about a constant, right? It's like a constant, but it's a named constant, and it's attached to almost like a static class we create. Like the enumeration, if I call it, it's a collection of common words that we use that have a value in the background, and the value for us doesn't really mean anything right now. Here's an example of a good enum. Let's suppose I'm making a player. All right? Actually, let's do it. I want you to do this in my diagram. We're not going to use this enum in my code, but we're going to make a new one, right? I want to have an idea of some player states. Okay, so I have a player in a game. Okay, anyone not ever play any video games? I'm just saying, put it up your hand now. Might be some people who would ever play video games. So a player does, or some kind of player that I control has different states. All right, let's talk about these states in the real world. I'm going to add a new enum. Here's my enum. And we're going to call this, this state, we're going to call this enum player states, right? Player states, just to understand more of another example here. All right, well, let's talk about how many player states there are. Let's add a new member, And the first state would be the idle state, right? Idle state, the player's just sitting there and he's waiting for you. Sometimes he'll just do this too. In some new games, he goes, "Come on," you know. That's his idle state. He might have an idle animation in the game, right? He'll just sit there and he'll just breathe. That's his idle animation, right? He's just breathing, right? That's all he's doing. Okay, so we've got idle as the player state. Let's add another one. How about walk? That's a player state, right? I'm idle, I'm walking, right? Let's do another one. Run, right? How about fight, right? How about die, right? These are all kinds of player states, right? Do I really care what the background value is of these player states? Is it a 1 or 2 or 3? Do I care? No, I don't. But I do care about this. And I only want to limit my game so it has only these player states, no other player states. This is why I create enums. It's a representation of a concept, right? An abstract value, like a label, walk, die, maybe fight, you know, whatever. Maybe I want to talk, you know, turn left, turn right. If I want to really have those kind of states, I don't have them. Usually it's something like this, right? A jump might be the other one. Let's do that one, because I forgot that one. I don't even care which I don't have to you know, put these in order either. Doesn't matter. The order doesn't matter for my player states. The order is going to be whatever I want them to be, right? Okay, let's go look at the player states enum. What does it look like? It looks like this, right? These are my enumerations. And if I ever want to create a new player, if I want to you know, actually give a player a state, right? I can go player states dot idle. So my player state is idle. And actually, when I look at the code, it makes sense. I look at it and go, he's idle. I don't care what the background value is. What if I said player state is equal to 0? What does player state 0 mean? Nothing, right? There's no contextual value. If you look at my code tomorrow, you're going to go, what does player state 0 mean, Tom? Unless I document it somewhere, you won't know. But if you'll know right away, this code is documenting itself. Player state idle maybe is 0, right? That's what it is. If you hover over it right now, it is, right? But I can change it if I really want to make a value of it. I don't need to make a value of this as well. So player state is one way of we can create almost like states or a concept of states. Here's another really cool value. I'm going to kill this enum, by the way. This is just an example for you guys. Let's make another enum, right? Well, and the idea of states. All right, I want to make a game, right? I want to add a new enum, and I'm going to call this scene states. Okay, scene states. And you might say, what are scenes? Well, imagine the start scene, right? So I'm going to have a new member called start. This is my first scene, my start scene, right? And then I want to go to make another member. You know, I want to pay the level 1 scene. Here's my level 1 scene, right? And you know what? Maybe I'm going to make one for each one. Here's my level 2 scene, right? And let's keep going. Maybe I only have 3 scenes, 3 levels of my game, level 3. And then maybe I also have my game end scene, right? So my end scene. And I also have some kind of instruction scene. So if I want to switch between the scenes, I want to say scene states start, scene states level 1, scene states level 2. And what I've done is I've created a state machine, the ability for me to switch between one scene and another, right? And I don't care what the value is of the scene in the background because it's not important. The important thing is that in code, I understand what I'm doing. I'm switching from one to the other, and I can contextually understand what I'm referring to, as opposed to guessing what scene 0 is. I'm thinking scene 0 will probably be start, makes sense. What about scene 3? Is that level 3? Is that level 2? Is that instructions? What does it mean, right? I don't know what it is. So this way, it gives me contextual value to these things. Clear as mud? Let's get rid of this thing. So now here's something I can do. I can kind of select both these things, right-click, and I can remove them from diagram, or I could even delete the code. Let's delete the code. So they're actually gone from my solution. Be careful. If you delete the code, it's gone, right? Any questions around the diagram? I'm bringing the diagram not to confuse you, but actually to help you. So when we create things like the next level of stuff we're going to make, like for your next assignment, which I'm going to hand out next week, all about interfaces and stuff like that, I want you to use the diagram. I want you to start building stuff out with the diagram, right? And we're going to do that today too. So this is lesson 5 class diagram, right? I can add to it and mix it up or whatever. What about if I want to do another little example? I want to do, you know, here's my solution, right? And lesson 5 class diagrams inside of my lesson 5 project, right? Let's add another project to my solution here, just so we can talk about exactly what we talked about before. I want to go over the person and teacher and student, all that before, but I want to do it in another project so we don't dilute, you know, pollute my deck and card class and all that kind of stuff. Right click here. I'm going to go add new project, right? On my solution I'm clicking, right? And I'm going to call this new project. I'm going to click which one I want. I want a console application again. And I want to call this new project, just to make it quick, right? Because it's inside this other solution. We're going to call it the, you know, person project, right? Right. So we can understand how this works. It's still inside the same solution, but my namespace is different now. Person project, right? I've got a driver class. It's the program class, but we're going to do every piece of code through the diagram, right? So how do I do that? So I'm here in my person project. I'm not clicking on my lesson 5. Okay, so don't click on lesson 5. We're not going to touch that right now. I want to create a new diagram. So I'm going to go add. And if you've done it before, it normally would appear in your quick hits down here. Diagrams don't. You're going to go new. And if I go class, if I just type diagram here, right? Class diagram will be the only one that comes up. But I can change this to person class diagram. That's really what it is. Here's my person class diagram. Add. And I got a new class diagram only attached to this project. It's not attached to the other project, right? All right. I want to do all my classes from scratch, right? But through my diagram. So let's make the person class. So here's how we do it. Add, new class. We're going to call this person, right? We're going to make it public. You can change the access modifier right here. Public, internal, or default. Let's use it public, right? And here's my person. You can change the name of the file, person.cs. Here it is. Here's my person class, right? My person class is pretty darn empty right now. I want to do a couple things here. I want to add 2 things like we had before. We had age and name. Let's do that. So I'm going to right click and add a new, I want to get a new property this time, right? So we're not going to do instance variables because we're going to do instant properties here. So property, we're going to call this thing age. We're going to add a new property, name. Okay, I'm not going to check the code right now. All I'm doing is constructing because I'm just visually, kind of creating my class. All right, when I'm coding. So age and name properties. Okay, now in my age and name properties, remember we had some constructors that allow me to, get my age and my name, right? So I want to make a new constructor. Here's my constructor right here, right? In my constructor, right now it's a basic constructor, but how do I get more details, right? Well, if I right-click on this thing, right, I can look at class details. Class details. It's going to pop up a little thing on the bottom of their screen here, and if I pin it for a second, spin it up, you can see that I get a visual representation of everything I got here. My name is age is an int, and my name is by default the type is int. That doesn't make any sense. Let's change this to string type. Right? Here's my string type. It'll help me code it up. It's public, right? My person method, right, which is my constructor method, is also public. I don't have a type for it. If I open it up, I can add parameters. One of my parameters that I want to add in is age. And the other one I want to add in is, and age is not a string, age is an int. Oh, there we go. And let's add another parameter. My other parameter is name. For my constructor, my name is a string, right? I don't have a modifier here because I don't need a modifier, but that's my person constructor, right? That's what it is. Now, I need to do some work still. It's not finished. But you can see how I'm building my class up, right? The basics are going to start being there in a second. Okay, what other thing can all people can do? They can all, speak, right? So we'll add that method in. I'm going to add it over here in my class diagram. I'm going to go add method, right? We're going to call this the speak method. So person speaks, right? Or speak, whatever you like to call it as. So here's my speak method. My speak method is going to add on down here, right? Here's my speak method. Does my speak method need any parameters? No. So we don't need any parameters for my speak method. It's just going to do something. All right, cool. I think I've got enough to start off my class with, right? Now, I don't know what any of these things do, right? All I know is that I've got a shape to my class. This is the shape of my class. My shape is what properties do I have? Do I have any fields, instance variables? Or do I have any methods, and including a constructor method? That is the shape of my class, right? Let's make another class that derives itself from this class. We'll call it student. I haven't coded this class yet, right? Let's go new class, call it the student class, right? Here's my student class. And I want to derive this class from the other one. If I look at my toolbox, right? I want to click on inheritance, and I want to say that, well, this one kind of inherits from this one, right? Well, look what happens. Did I do it the right way? Undo. Control Z. Let's do that again. So in my toolbox, I want to grab inheritance, and I want to take this one, the student class, and pull it across from here. That makes more sense. So student derives itself from person. I'm visually drawing my stuff, man. I'm visually coding, all right? It's almost like coding for kids, right? Notice what it's done. It's done a little like arrow, like that kind of shows one class that derives itself from another. All right, let's do another one. We don't know anything else about the student yet. But we want to do another class down here called teacher. So add a new class. Oops. Add a new class called teacher. A teacher class. There we go. And teacher also does the same thing. So I'm just going to leave my toolbox pinned for a second. And I'm going to take my inheritance. I'm going to drag it from here to here, right? Now my teacher also inherits from person. Both classes exist. My person class influences these ones, but these ones are going to have specific values compared to what I have before. An example of this is my student class is going to have a student number. So let's add that student number property. So property, and we'll say student number. Right? And if you don't like this, if you don't like student number, then you might want to just call it number. But number is a key value, right? So we don't want to use number in any way. So student number is okay. Or student num, whatever you want, if you want to cut it down. All right, and then teacher also has another property. It's got employee number. Employee number, student number. Make this a little wider so we can fit it. And notice that and I can move these things around, like down here. Notice that the student also has a couple of other values. One of them we talked about was studies, right? So it can study. So method, study method, right? And we don't know what it does. We just know that it's a study method. And it doesn't take any values right now. We just can enact it. And the same thing goes with teacher. Teacher teaches, right? So new method, we'll call it teach, right? Are you getting me? Inheritance, I can do this stuff because both a student and a teacher are both part of the person class. They both are, they have an is-a relationship. A student is a person. A teacher is a person, right? But a teacher is not a student, not necessarily, right? There is no relation between the two directly. They're two siblings of the parent class. This is the parent class. These are the two child classes. All right. Let's make another one. We'll make another class. We'll call this international student. International student is also derived. If I go back to my toolbox, But the derivation is a little different now. The derivation is not a person necessarily, but actually a student type. Multiple inheritance, right? We're talking about different layers of inheritance. So an international student has a student number, it has an age and a name, right? But what is different about the international student is maybe it has a different address or something else that makes him different. Or maybe the his rate is different than the student's rate. For now, let's just leave it as is. I also have a domestic student, and there's difference between the two, right? So I can add another one. So add class. And instead of international student, we'll call it domestic student. The domestic student. And my domestic student is also going to derive itself from the student class. There we go. Does domestic student and international student have anything to do with teacher? No. Do they have anything to do with person? Yes, because inside the inheritance chain, right? An international student is still a person, but it also has an is-a relationship with a student. An international student is a student, is a person. Both are true, okay? International student does not have an is-a relationship with teacher. Neither does student. All right. It's important. We're just drawing this out because, you know, we're making the classes. We have a student number, and we have a, study. They both study, international students and domestic students. Maybe they do something different. Is there another activity you guys can think about, or something else that international students do that domestic students don't do, as opposed to just pay? They don't pay more, kind of stuff. It's something else that they do differently. And if there's no difference, there's no reason for my classes to exist. Remember, it has to mirror the real world in some difference. There's got to be a reason for international student over domestic student if we're going to make that. If we're going to make that distinction. Remember that international student is a specialized student. So is domestic student. Domestic student is a specialized version of our student class, right? If there's no specialization, if I just leave them like this, they don't need to exist. I'm just showing you the diagram, right? Okay, cool. Let's take a look at our code now, right? So we got to look at all the stuff we just made in our code. All the classes and everything is here, right? And if I looked at my person class, I can see that a lot of the code has been outlined for me. Some stuff needs to be fixed. It's not working yet, okay? Like, for example, my person method doesn't really do anything. It says, throw a new system non-implemented exception. All this does is it's a stub that tells me how I got to implement my person method. I haven't implemented it. All I've done is outline, right? That's all I've done. Let's fix my person method to work, right? So I know that I have age and name properties, right? And here in my getter and setter, I don't have any instance variables, right? I could add them in later on. Let's go back to my class diagram. So in my person, I want to add in two fields. That's what instance variables are called, right? One field is underscore age, and the other one, another field, is underscore name. What I want to do here is I want to kind of do properties, right, for these fields. If I go properties, I can hit properties for anything I want. It's context sensitive. So if I go to my properties view, so let's look at properties for a second, and I'll pin properties up here so you can see it, right? By the way, if you want to get the properties window, you just go to view and properties down here. So properties window allow me to actually look at each one of these things and modify them on the fly. So access is private, right? My name is age, underscore age. That's our standards, right? And then my type is for age is int. That makes sense. For name, though, that doesn't make sense. It's got to be a string. So let's change this value to string type, right? That's good. And then if I look at my properties for age, right? Here's my age. And I have this part. Look at my instance modifier. Is there none? I can also pull down abstract of other things, other options I have down here. One thing it doesn't do, which I would love if it did, was actually to connect my my instance variables with my properties. You got to do that yourself. I mean, it can't do it all for you, right? Sorry, hate to burst your bubble, but there's got to be a little bit of work. Double click. Double click now. I got my private age and name, right? Well, I can do the same thing. So I can go down here and say something like this. I can say this dot, I'm returning, right? So return this dot underscore age. That's what I do with this one. And this set actually says this dot underscore age is equal to value, right? So that's my getter and setter for my age. I got to do the same thing for name. Return this dot underscore name, right? And here, this dot underscore name is equal to value. Notice that I get this. This value is grayed out, right? It's always grayed out. And Visual Studio will say name can be simplified. You don't have to use that at all, right? You can remove this reference anywhere, right? We're using it just so that way you guys can get used to the idea that this means this class, right? Here's another thing we have to fix. Speak. Speak is wrong, right? Speak just says nothing, right? So speak, we're going to do a a console log that says, or console write line that says, the name of the person, whatever the name is, right? How do I do interpolation? It's like this, right? 0, right? Says hello. He's speaking. And 0 is the name of the person, which is this dot name. I'm going to use the actual the getter for my property as opposed to directly accessing my instance variable. That's the right way to do it, even inside the function or the class. All right, so we got some functionality here. We've even got this, but we got to fix my person constructor because my person constructor makes no sense, right? I got to say something like, this dot age, capital A, is equal to lowercase age, local variable. This dot name, capital N, is equal to lowercase n, right? So we're never immediately accessing our private instance variables. I also don't have any comments. I can start adding comments in here. This is just an example, so I'm not going to go into the details about adding comments and all that stuff, but you certainly could do that in here. All right, now I've got some values, and you can see that how the class diagram is coming up. I've got my person method, which is actually a constructor method, and I've got my speak method, which actually does something. Students can speak too, so can teachers, right? Students can also study. Let's take a look at the student class by double-clicking, right? And I've got a student number, which is an integer, but it doesn't. I don't have an actual integer value for it. And notice also I have a problem. It says there is no argument given that corresponds to the required formal parameter of age, right, for the person. Why? When I create a constructor, I don't have a constructor for the person class, and that's why it's giving me this error. Oh, you'll see. Because remember, in my person, I added a constructor that has this, right? So in order for me to build my person, I need to add, my student, I need to do this. Let's fix this problem. And the way to fix this problem, of course, is in the class diagram first, right? I want a constructor for the student. I'm going to pull this over here like this. And my constructor is going to take not just age and name, but also student number when I create a student. So when I go new constructor for my student, if I notice on the right, if I use the properties, here's my on the right. Take a look. I have my name as student, and I have my summary, so you can see what kind of access it has and all that kind of stuff. I can also add custom attributes to it if I wanted to, but one at a time. I can do it here, or in my class details, I can bring this up, and I can see that the student. I'll pin this up for a second so you can see it. My student under my class has 2 parameters. One of them, or 3. One of them is going to be my my age, right, which is an integer, and then my name, which is going to be a string. And then I also have another one called student number, which is going to be a string as well. We'll make it a string, right? So those are the 3 things that's taken into my method, into my method itself, right? Now, if I double click on my student and I hide these things, you can see that my student, it takes in a constructor. See that error is gone from up here? But I need to call the base constructor when I use my own constructor. I need to call base. I need to pass in the age and the name, and that's going to take away my issue. Yes.
Can you select the constructor?
my class details?
Yeah.
Yeah, so in my class details, I pulled that up. In my class details, I just added in these, a new parameter. I can add a parameter by clicking this button here, right? Let's go back to my student. So here's my student. It's giving me an error because I need to pass in age and name because my only constructor that I've defined in my person requires age and name, and therefore I have to use the base class constructor call to pass in the age and name that I'm taking from my student constructor and pass it into my person constructor. That's what I'm doing here. Now this makes no sense, right? I want to assign all those values, right? So I'm going to say this dot, and I have access to this dot age. Do I have to do this dot age is equal to age and this dot name is equal to name? No, because it's being done in my base constructor. I don't need that, but I do need a private instance variable to hold, right, my student number somehow, because my student number is not associated with anything right now. It's also an int, which just makes no sense. Student number should be a string, right? And I can code as I like, right? If I want to code everything in my person diagram, my class diagram, I can. Just save this thing. When I save my class, it reflects in the class diagram. Anything I made, any change I made here, reflects in my class diagram. Give it a second while my Visual Studio updates. So you can see that my person, my student, is here. If I want to see more details again, I can click on this button here, so I can see all the details of my entire signature, which is really important actually when I'm constructing stuff. Right? I want to be able to see everything. There's my real signature for everything. Right? Here's my real constructor from my student constructor. There's my constructor method. Right? And you can see that what I'm getting my employee isn't absolutely correct. So I've got to fix my teacher in a second too. So student number, I need to get I need a field for that called student number. Right? By the way, you can call it student ID or whatever as well. I just call it student number here. It's instead of an integer. See how it defaults to an integer. On the property side, I can fix that. On this side, I can make it a string. So I can kind of hit that, go string on the right side. So it automatically updates this way. And my student number is also a string, right? But I want to make it relate. Let's take a look at over there. So I made this relate. Does it actually relate to anything else that's up here? And the answer is my property signature is here, but there is nothing that shows me that I'm relating to doesn't read the actual property here, the one I did for person, right? So I got to code it by myself, right? So double click, go back to my student, and I can see that I now have a student number as part of my student. And down in here, when I'm correcting my my student number property, I can do that here. I can say return this dot underscore student number. That's what this does, right? And the setter, it takes the student number and assigns the value that I put to it. Value is a keyword. Okay. Here we go. So student number, student number. I've done this thing. I've created my properties and my student number. Now I can go in here, my constructor, and do this dot student number is equal to student number, local. That's my local student number that I get from my constructor. I assign it to my student number, which is my property, which further assigns it to my private instance variable or member up here. Right? Okay, student is done. Except for my study function. My study method doesn't do anything. So I'm going to do a kind of a console write line, and I'll say the student name, whatever the student name is, right? And he studies or studies, let's say, right? So I'll say, so whatever the student name is, so name is studying, right? So and comma the name, which is this dot name. I do have access to that, even though I haven't defined it in this code. But that's what this thing does. Any questions around this stuff? I can keep going with this example, but the idea here is that I'm starting to create my classes first from the diagram, and then so I can visually understand how they relate from one to the other. I don't have to make my connections by hand. Like for an example, when I drew this line, it automatically created the inheritance changes, right? If I go to student, you can see that at the top of my class, I have this colon that says student is a person. This colon, that's what it represents. It extends the person class, the person class. We can also say it that way, right? So I'm not going to continue with this example, but you can see I want you to figure out, if I was going to figure out this, a teacher, I could fix up the teacher class, and the same thing with international student, domestic student. If I had some kind of need for that, I could do that, right? Any questions around designing things visually with the class diagram? And why I'm getting you to do that. We're going to do the same stuff, the same examples. When we come back, what I want to talk about is interfaces and abstract classes and a bunch of other stuff, because we really need to talk about polymorphism a little bit more, right? We've only kind of scratched the surface. I've been really playing with classes and objects with you over the last couple of weeks, right? Because I want you guys to get comfortable, because everything we do in C# or any other language, in Java, C#, even JavaScript in some ways, we're using objects all the time, always, always, always. Whether they're built-in objects like the list object, list class, right, like we talked about before, or whether there's something we've created here like the person class, right? So let's take a short break. When we come back, we'll talk some more, some other things about inheritance and interfaces and stuff like that.